electric field strength between parallel metal plates. Consider two parallel metal plates connected to a DC power supply. Let V be the voltage or the potential difference across the plates, and D is the separations between the plates or the plate separation. Then the electric field strength E between the plates is E equal to V over D. Remarks 1. The electric field strength E between the plates is uniform. When a charge Q is placed inside the regions of the plates, the electrostatic force on the charge F will be F equal to QE. Since E is uniform, therefore this electrostatic force is also uniform or constant. Second, electric field lines inside the plate regions are parallel and from positive plate to negative plate. Third, electric field strength can be increased by increasing the voltage or by decreasing the separation between the plates. Question number 1. The electric field lines E between the plates are uniform and from positive plate to negative plate and are parallel. For part B, the electric field strength between the plates equal to V over D equal to 2000 over 0.05 meter, which is equal to 4 times 10 to the power 4 volt per meter. For part C, the electrostatic force on the charge P is equal to QE equal to 8 times 10 to the power negative 17 times 4 times 10 to the power 4, which is equal to 3.2 times 10 to the power negative 12 Newton. And this force is pointing towards the right. Question number 2. Part A. Electric field strength between the plates is E. The force on the electron is F equal to QE 6.4 times 10 to the power negative 18 equal to 1.6 times 10 to the power negative 19, which is the charge of electron times electric field strength E. Therefore, electric field strength E equal to 40 newtons per coulomb. For part B, the electrostatic force on the electron is towards Q. Since the charge on the electron is negative, by F equal to QE since Q is negative and force and electric field strength are vector quantity, therefore the electric field strength between the plates acts in a direction opposite to that of the force on the charge of electron. Therefore, the electric field lines acts in opposite direction to the force. As a result, Q is at a higher potential than P. Question number 3. The electrostatic force on B is F equal to QE equal to QV over D equal to 1.6 times 10 to the power negative 18 times 3000 over 0.02 meter, which is equal to 2.4 times 10 to the power negative 13 Newton. And the force on B is direct towards the left. For part B, the acceleration on the charge is equal to F over m, which is equal to 2.4 times 10 to the power negative 13 over 0.01, which is equal to 2.4 times 10 to the power negative 11 meter per second square. Since the electric field strength inside the plate region is uniform, therefore the force on the charge is also uniform. That means the accelerations on the charge is also uniform inside the plate region. Hence, we can use the equation V squared equal to U squared plus 2AS to find the speed of the charge just before it hits the plate wide. V squared equal to 0 plus 2 times 2.4 times 10 to the power negative 11 times 0.02. Therefore, the speed V can be found using the square root of this one. Question number 4. There are 3 forces acting on the ball. First, tension. Second, the weight of the ball. Third, the electrostatic force, FQ. To find tension on the string, we have T cosine 20 degree equal to mg equal to 5 times 10 to the power negative 3 times 9.81. Therefore, T equal to 0.12 Newton. For electrostatic force on the charge, we have T sine 20 degree equal to FQ. Therefore, FQ equal to 0.11 Newton. The electric field strength between the plate is E equal to V over D equal to 5,000 over 0.1 meter, which is equal to 5 times 10 to the power 4 volt per meter. For the charge Q of the ball, we have F equal to QE, that 0.11 equal to Q times 5 to the power times 10 to the power 4. Therefore, the charge on the ball equal to 2.2 times 10 to the power negative 6 coulomb. Since the electric field strength inside the plate regions is uniform, therefore, even though the charge is moved in the regions between the plates, the force on the charge Q equal to QE remains constant. Therefore, the deflected angle of the strings remain constant. Question number 5. There are two forces acting on the charge. The first one is its own weight, mg, pointing downward. In order to make it at rest, the electrostatic force acting on the charge should be vertically upward. Therefore, P should be negatively charged. At equilibrium, F on the charge Q, Fq equal to mg. We have Q E equal to mg, Q V over D equal to mg. Q 5,000 over 0.05 equal to 10 to the power negative 5 times 9.81. Therefore, the charge quantity is 9.81 times 10 to the power negative 10 coulomb.